Uh, we know that an expression like this one, p of x equal a constant en xn x power n plus another constant and x, and yes, for example, up to e1 x plus e0. We call it a polynomial. Okay, is a polynomial. So where with, and we specify usually with degree n, with and degree, so the degree of the polynomial p of x, we look at the highest power of the variable x, so which is n, and we say the polynomial is degree n. These quantities are called so ei, xi. Okay, R is a term, the ES term of the polynomial. And yes, what else? And the AI are the coefficients. Okay, AI are this coefficient. We call it a coefficient of the EM term coefficient. Okay, so now this definition is extended to more general. So this is the first. So this is what we know about polynomial, but it's extended to polynomials with several variables. So they have several variables x and. So it will be like a sum, okay, a sum of terms. So the terms will depend. So yes, en. Let's see how we can do that. So we have x1, let's say alpha 1, x or n1 instead of alpha, yeah, n1, x1. Um, how can I do that? So yes, and e1, x2 and e2, etc. xn and en. Okay. Suppose that we have, sorry, here we have an e, n, okay, and here and e2. Okay. So, and we are, yes, adding over all possible index e1, e2, en. Okay. So we have here e1, en. Okay. And there's numbers and there's the variables. Then, so we will have, yes, similar expression, but with more variables. Okay. And then the degree of these several variable polynomials, okay, polynomial will be so the highest, okay, so the highest sum, okay, so we will have um, the highest sum, so the maximum where we can say an e1 plus an e2 plus an en. The highest sum will be our the degree of our polynomial among all the terms of the polynomial. Okay, so let's do an example about that. Yes, first example. So this is the summary, and now let's start doing an example. Suppose I ask you, I give you an expression, and the purpose is to identify the degree of the polynomial. So here is my first expression. P of x is 2 power 7 minus 5 times 2 power 3 plus 2 plus 5. So what is my degree of my polynomial? Again, what about p of x equal x power 7? Third, p of um, x and y is minus 7, y or z 7. Okay, so here The first one, what about the first one? The first one, I see that they have powers. Is it then the degree the highest is 7? What about the variable x? Does it appear in the expression? No. So here, this is just a number. I can compute it, and it's a constant number. It's an A0, okay? It's a constant. So this one is exactly an A0. That means it's a constant, and then that means it's like an E0 x power 0. So the degree of my, so the degree of my p of x here is exactly 0, okay? What about this one? So it's a polynomial with one variable x, and see I have one term with degree 7. So it's the only one. So my degree also here, I can read it easily. Okay, will be 7. This time in the third example, I have two variables. So, uh, but I change it now. Here I should write an x. I don't have z. Okay. So I have two variables, but one term. So I need just to compute the to add the two powers. So the degree, I will say that the degree, we add the powers 4 plus 7, which is 11. Okay. Okay, let's continue then. What about if I give you now the example of p of x, xy again? So you have x7 minus 7 y4 x7 and minus 5 y7. What do we think here? What it will be the degree? So the definition for several variables, we said we will take the maximum, the highest, so sum of the degrees of different variables corresponding to different variable in one particular term. That means we will compare all the degrees. The first term here, its degree is 7. This first term, it's like the previous one, okay, 4 and 7. So we know it's 11, and this one will be 7. So the highest among of them will be the degree of p of x, okay? So it is the maximum among 7 and 11 and 7. So it will be 11. So this is how the definition allows us to know, to compute the degree. Okay. So let's then do more. Yes, let's do another example here. So this is the summary. Sorry, box, box here. So I want to put in the box. Yeah, it is. Okay. So, yes, another example here is the following. What if here is the polynomial this time? A polynomial. So each time be careful about the variables. Okay. So it's minus 5 x7 z4 y7 plus y4 y power 4. Again, here I have two terms. So the degree of this term will be, so let's do it step by step. The degree of this term, minus 5x7 z4 y7, will be then 7 plus 4 plus 7. So it will be 14 plus 4, 18. The degree, the other term, y4, is just 4. Okay, so the degree of p of x, y, z, x, y, and z will be the maximum of those two. So the largest one is 18. Okay, so this is first one. What about the second? This, if I'm given now three variables, you have 7x plus 4y square plus z5 times minus 5x8 z4, okay, and yes, y4, and what else? Plus y4. What about the degree of these polynomials? So a way to do it is to develop, a direct way is to develop this expression, write it as a sum of simple terms, okay? Evaluate the degree of each term and look at the highest one. But we can avoid this long work. We can just see which one will give me the highest. I see here the degree of this term, we saw it, its degree, or yes, the degree of this term is 18. So if I do my distribution multiplication, so I will have here this term with degree 18. If I add 5, I will add 5 if I multiply this term. So I will have 23. So I can say the degree of Z5 times minus 5 x8 z4. So it's something we can do mentally. So it will be 18 plus 5, which is 23. Now, if I multiply by the others with 4y square, I will get a lower degree, you see. For example, y2 times the same term, because this one is dominant here compared to y4. Y4 combined with z5 will give me just degree 9. With y2 will give me degree 6, then degree 5. So it's lower. This one was more dominant as for degree highest. So we will look also for the highest in the other term. That gives us the highest. Look, for example, with y2 or 4y2 times minus 5 x 8 z4 the y4, I will get a degree of 2 plus 18, which is 20. So it's clear that the degree of my expression p of x, y, z will be 23. Okay, so this one is dominant. With this one also is the dominant. The degree here is of this term is 5. So that are the highest. The degree of this one is just 2. The degree is 2. For this one, the degree is 1. Here the degree is 4. So which term, when you multiply, you do your multiplication will give you the highest. It's clear that there's 2. Okay, those two will their degree together will dominate the other terms. So this is how we look for the degree of polynomial of several variables.